Imagine handing over the mouse and keyboard of your company's 20-year-old incredibly fragile legacy CRM to an AI, not through some highly restrictive API, but literally letting a bot click the buttons, read the screen, and navigate the menus on a virtual desktop. It sounds like an absolute nightmare for a system administrator, right?
Oh, yeah. I mean, it sounds like a fast track to a catastrophic outage.
Exactly. But as of this first week of July 2026, that is exactly what enterprise infrastructure is becoming. We are moving from human-operated systems to environments that are, hyper-autonomous. Welcome to the Deep Dive. If you're listening to this right now, you are likely a cloud architect, a cybersecurity professional, or maybe an AI engineer. Your time is valuable, and you need to know exactly how the tectonic plates of enterprise tech are shifting this week.
Because they are shifting violently. If we look at the raw data from just the past few days, we are seeing deployment speeds essentially quadruple, AI agents being handed the keys to live operating systems, and foundational communication protocols being completely torn down and rebuilt.
It is a lot to process. Before we get into the weeds, a quick transparency check for you listening. The summary for today's discussion was compiled using Notebook LM to help us synthesize everything. However, absolutely everything we are about to unpack is based on actual, factual public sources from the latest weekly news updates. No hallucinations here.
Just the raw mechanics of a rapidly changing industry.
Right. So let's start at the foundational layer. If we're moving toward an autonomous enterprise, the underlying infrastructure has to be able to keep up. And this week, AWS really hit the gas pedal hard. They just pushed their CloudFormation and CDK Express mode to general availability. They're claiming like up to a 4x speed up on deployments, which honestly sounds like marketing magic. How are they actually achieving a multiplier that massive?
Well, it's not magic. It's actually more about what they've decided to stop doing. To understand the speed up, you have to look at the traditional deployment engine. Historically, when you deploy a stack, the engine applies the resource configuration and then it just, waits.
Right, all the extended stabilization checks.
Exactly. It waits to verify traffic readiness. It waits for the global region propagation to finish. It waits for background cleanup tasks.
Which, if you've ever waited on a CloudFront distribution to deploy globally, is an exercise in extreme patience. I swear I've aged years of my life just watching those loading wheels spin on the AWS console.
We all have. But with Express Mode, they bypass that synchronous waiting period entirely. The engine completes the stack operation immediately after the resource configuration is applied locally.
Oh, wow. So high latency resources return control in seconds.
Yes, in seconds. The configuration becomes active immediately, allowing the next steps in your pipeline to proceed. Meanwhile, all that edge replication and global propagation just happens asynchronously in the background.
Okay, I see where they get the speed, but I have to push back here. To make this work, they changed the default behavior for rollbacks, right? Automatic rollbacks are disabled by default in Express Mode.
They are, yes.
To me, that is like taking the governor off a go-kart. Sure, it's incredibly fast, but if you hit a wall, you're flying through the windshield. Is disabling automatic rollbacks actually safe for a production enterprise environment?
It's a very valid concern, and it's one a lot of architects are raising right now. But it requires a real paradigm shift in how we view cloud debugging. Think about the traditional automatic rollback. It's a lengthy, painful reversal process.
Oh yeah, you wait 45 minutes for a failure and then another 45 minutes for the rollback to square one.
Exactly. Express Mode disabling rollbacks is designed for a fix and retry paradigm.
Wait, meaning you fix it while it's broken instead of resetting.
Precisely. It allows an engineer or an autonomous AI agent managing your stack to apply a patch directly to the broken state in seconds. You don't wait for a rollback. You just rapidly iterate forward until the state is healthy.
That makes sense. But it also creates a new problem. If AWS is letting us deploy infrastructure in seconds, our visibility into that infrastructure has to be just as fast. Speed without visibility is just a fast way to crash a system.
A very fast way.
Right. And if your environment is changing asynchronously in the background, those old static event counters we rely on are entirely useless. How are engineers supposed to actually monitor a blast radius that moves this fast? Did the Google Cloud Telemetry update solve this?
It did in a very elegant way, actually. Google Cloud just put a new SQL alerting engine in their cloud monitoring observability analytics into preview. What they've done is allow engineers to write complex analytical SQL queries natively over their logs and distributed traces.
Wait, let me make sure I understand this. Usually my alerts are just basic thresholds, right? Like, alert me if 500 errors go above 5%. How is writing SQL over logs different?
Because basic thresholds fall apart when you introduce high cardinality data. Let's say you need to track real-time error percentages across highly specific, unique user session IDs.
Or individual ephemeral IP addresses generated by an AI agent pool.
Exactly. A static threshold can't track millions of unique IDs dynamically. But with this new engine, you can write a SQL join that combines logs and distributed trace metrics inside a single rule, natively querying that high cardinality data.
Oh, I see. So you can get incredibly surgical. You can tell the system, run this complex query every 5 minutes, and if this highly specific subset of user sessions throws an error, fire an alert.
Precisely. It ties into a BigQuery dataset, and you can trigger it using row count conditions, like if this query returns more than 50 rows or complex Boolean logic, pushing targeted notifications directly to Slack or PagerDuty.
All right, so we are moving fast, and we have deep visibility. But moving fast still means breaking things. That is just a law of physics in IT. And when a script or a compromised AI agent breaks your core directory, you need rapid recovery. Which brings us to Microsoft Entra Backup and Recovery hitting general availability. We're finally seeing the shift from clunky point-in-time restores to full tenant recoverability for workforce tenants.
This is a critical safety net. During the public preview, Microsoft offered a 5-day retention period. For this GA launch, they've extended that object retention to 7 days. The native service automatically performs daily backups of your core directory objects.
And we aren't just talking about user accounts and passwords here.
No, and that is the most important part for cybersecurity professionals listening. It backs up your managed identities and your conditional access policies. If a bad automated deployment wipes out your conditional access policies,
Your entire perimeter is just gone.
exactly, it's gone. You need to get them back instantly. Furthermore, Microsoft built this with an API-first framework.
Meaning you don't have to manually click through a portal to restore a tenant. You can automate the recovery workflows entirely or plug them directly into third-party tools your enterprise already uses.
Right. It's an accessible framework for enterprise resilience, which you absolutely need if your infrastructure is highly automated.
So let's connect these pieces. We have infrastructure deploying in seconds, telemetry tracking millions of unique IDs dynamically, and automated API-first backups. Human beings simply cannot manually secure an infrastructure that changes this fast. The security itself has to become autonomous. Which leads us to the Google Cloud CISO Perspectives release this week, detailing how Google uses AI internally for their own software development lifecycle.
Yeah, the CISO Perspectives give us a fascinating look at the Mantis framework. Google is deploying specialized modular AI security agents to automate threat modeling.
Taking what used to be a static manual whiteboard exercise and turning it into a dynamic pipeline.
Exactly. But if you're an AI engineer listening to this, your immediate thought is probably about token overhead. Feeding a massive enterprise code base into a large language model to scan for vulnerabilities is a fast way to bankrupt your entire department.
Oh yeah, the computational costs are astronomical. How's Google avoiding that?
That is the genius of the Mantis framework. It's a multi-agent system that doesn't just blindly read millions of lines of raw code, it builds context-aware code summaries. By abstracting the code into structural summaries first, Mantis slashes token overhead by over 85%.
Let me see if I have a good analogy for this. So instead of forcing the AI to read every single word of a 10,000-page textbook and billing you for it, Mantis is essentially giving the AI the cliff notes, the structural map of the code, so it only analyzes the specific chapters it actually needs to secure.
That is exactly how it works, and it solves the other major problem with AI security scanning, which is hallucinations. Traditional scanners throw thousands of false positives. Mantis filters those out by utilizing isolated sandbox environments. It physically verifies the vulnerabilities it finds.
Wait, meaning it actually compiles the code
Yeah.
and attempts to exploit its own findings in the sandbox?
Yes, it proves the vulnerability exists before it ever wakes up a human developer. And if their autonomous security posture management engine detects configuration drift in a live system, it doesn't just send an alert.
Don't tell me it fixes it itself.
It applies self-healing remediation on the spot.
Okay, so AI is actively auditing and fixing code. But AI isn't just living in sandboxes anymore. It's driving the car. Which brings us back to that terrifying scenario I mentioned at the start of the show. Amazon just announced the general availability of Amazon Workspaces for AI agents. They are literally giving autonomous models managed virtual desktop environments.
I know it sounds counterintuitive to give a computer program its own virtual computer screen. But if we look at the enterprise reality, it solves a massive bottleneck, which is legacy APIs.
Right, because building custom API integrations for a custom ERP from 2004 is an absolute nightmare.
It's costly, it's brittle, and in many cases, those APIs simply don't exist. By giving the AI a workspace, the model can view and interact with these legacy systems exactly like a human operator does. It uses direct visual operation.
It is literally moving the mouse and clicking the buttons.
Exactly. And Amazon is doing this using Native Model Context Protocol, or MCP, integration. This allows the models to control the applications and the operating system via structured programmatic calls, which drastically reduces inference latency. But to your earlier point, giving an AI the keys to your legacy CRM is a massive risk.
Yeah. How do you put a leash on an AI that has full desktop control?
Granular session governance. Amazon built-in live telemetry. A system operator can monitor the agent's activities live, exactly like watching a screen share of an employee.
Oh, interesting.
And crucially, there is a kill switch. You can instantly revoke access or kill tasks mid-session if the agent starts doing something anomalous.
Okay, but to power these virtual agentic workspaces, you need serious computational horsepower. You need enterprise-grade foundation models deeply integrated into the cloud, which explains why Anthropic's Claude launching natively in Microsoft Foundry just hit general availability.
This is a massive unlock. You can now deploy Claude natively as a production-grade engine within the Azure ecosystem. Developers get all the frontier features: prompt caching, extended thinking, and an automated model router that optimizes latency and costs by up to 50%.
Which FinOps teams will love. But for our cybersecurity listeners, the nightmare scenario is sending proprietary company data into an LLM prompt, only to have it train a future model. How does the Foundry integration solve that?
Through ZDR Zero data retention. In sensitive production environments, you simply cannot have your prompts or completions stored by the API provider. The native integration in Microsoft Foundry mathematically ensures that all of that data is completely omitted from post-API call storage.
It's just gone.
The prompt history is vaporized the second the inference is done, allowing engineers to securely embed Claude as the central reasoning core.
And speaking of Claude, the models themselves are accelerating just as fast as the infrastructure. Anthropic dropped Claude Sonnet 5 this week. Now, Sonnet is supposed to be their mid-tier balanced model, but it is delivering frontier-level capabilities.
Sonnet 5 is incredibly impressive because of its autonomy. It introduces advanced multi-step planning, native tool use for both web browsers and command line terminals, and self-debugging. It can execute complete software engineering tasks in a single pass.
Which means it is basically custom-built for those Amazon Workspaces environments we just talked about.
Yes. If you look at the benchmarks, its scalable cross-performance is highly optimized for agentic search on the BrowseComp benchmark and computer use tasks on the AWS World Verified benchmark. And it comes with default cyber safeguards integrated specifically to mitigate exploitation when an agent is running live terminal commands.
But AI isn't just writing code and clicking GUIs. It is fundamentally changing how we do data science. Google Cloud just pushed conversational analytics in BigQuery to general availability. They've embedded Gemini-powered natural language processing directly into the data warehouse engine.
What's fascinating here is how it addresses the black box problem. A lot of enterprise leaders don't trust AI for data analytics because they can't verify how the AI arrived at the answer. BigQuery's conversational analytics exposes its multi-step thinking process.
So it actually shows its work.
Exactly. It surfaces the exact generated SQL behind every single response. You ask a question in plain English, and it shows you the exact SQL query it wrote to get the answer, so you can audit the reasoning.
That is huge for transparency.
And it breaks down data silos. It doesn't just read native BigQuery schemas. It can interpret unstructured files like PDFs or images, and it connects to external lakehouse sources like Databricks Unity and AWS Glue.
Wait, all from a natural language prompt?
Yes. You can ask it to run a root cause analysis on a metric shift, and it will map out an autonomous investigation plan, pull the data across clouds, and generate a shareable executive summary with predictive forecasting.
It's incredible. But as these capabilities scale up, as AI gets better at writing SQL, navigating terminals, and controlling desktops, the potential blast radius increases exponentially. The frontier models are getting so capable that we require entirely new defensive paradigms. And this week, we got a glimpse of the heavyweights. OpenAI revealed a limited preview of their next-gen model family, GPT 5.6. They've got the lightweight Luna, the balanced Terra, and the flagship, Sol.
The architecture of GPT 5.6 Sol is particularly noteworthy for these agentic workflows. They've introduced a max setting, allowing the model to use more test time compute for deep reasoning. But the real headline is what they are calling Ultra Mode.
Right. Ultra Mode automatically deploys multiple server-side subagents to execute complex tasks in parallel. And the benchmark results are staggering. On Terminal Bench 2.1, which tests command line iteration, Base Sol hit 88.8%. But in Ultra Mode, with those parallel subagents working together, it hit a record 91.9%.
With that level of parallel capability, the safety stack has to be equally advanced. OpenAI has implemented layered, multi-tiered defensive guardrails. They pair trained-in model refusals with real-time biology and cyber classifiers.
Oh, so it's constantly monitoring itself.
Exactly. If the system detects a potential high-risk misuse, it actively pauses generation midstream to invoke a larger, separate reasoning model to evaluate the safety context before continuing.
That is some serious defense in depth, which actually mirrors what Anthropic is doing with Claude Fable 5. Fable 5 was suspended briefly due to U.S. government export controls, but those have been lifted, and it is back in general availability this week.
And they use that suspension time to significantly beef up the security architecture. Fable 5 implements a heavily expanded safety margin classifier, claiming a 99% mitigation rate against known vulnerability exploitation prompts.
But there is a specific detail in the Fable 5 release I really want to push you on. Anthropic is introducing a unified jailbreak severity framework, modeled after CVSS, the Common Vulnerability Scoring System. They want to evaluate jailbreaks based on capability gain, weaponization ease, and discoverability. But does a deterministic scoring system like CVSS really work for something as fluid and non-deterministic as an LLM jailbreak? I mean, a traditional buffer overflow behaves the same way every time. A jailbreak is basically a psychological trick played on a neural net. It's chaotic.
It's an excellent question, and it highlights a major friction point in the industry right now. You are right, jailbreaks are highly non-deterministic. However, cybersecurity desperately needs a common taxonomy. We can't just treat every single jailbreak as an equally catastrophic event.
So they're trying to measure the actual impact rather than the technical mechanism.
Exactly. By evaluating capability gain, meaning what new harm does this specific jailbreak actually unlock, and combining it with weaponization, how easy is it to automate this jailbreak at scale? Anthropic is trying to bring order to the chaos. It may not be a perfect one-to-one mapping with traditional CVSS, but it gives security teams a triage rubric.
Which is much better than the current Wild West, where every prompt injection is treated like a 5-alarm fire.
Exactly.
Fair enough. We definitely need a shared language to triage these threats. And speaking of shared languages, how do all these highly capable agents actually communicate with each other securely? Because the foundational protocol for that just got a massive overhaul. The Model Context Protocol, or MCP specification, was updated for July 2026.
This is arguably the most critical structural update of the entire week. The MCP specification is shifting from a local single-user tool to a fully enterprise-grade stateless architecture. They are issuing a 12-month deprecation window for legacy functions. They are completely eliminating protocol-level sessions and high-value session identifiers.
Why is eliminating session identifiers a good thing? Doesn't that make tracking the agents harder?
Well, it's a massive win for reducing the blast radius. If you think about traditional transport-related authentication risks that plague agentic systems, attackers look for session tokens to hijack.
Oh, right. So if there is no session identifier to steal, the attacker's job gets way harder.
Yes. Hijacking an ongoing workflow gets significantly harder.
Okay, but moving to a stateless architecture always introduces a catch.
It does. The new stateless protocol layer introduces client-controlled tracking identifiers and a universal meta object. Because the server isn't keeping track of the state anymore, the client has to pass that meta object back and forth with every request. Think of it like a VIP pass at a club where the bouncer has no memory. You have to show the pass every single time you walk through a door.
And if someone forged the VIP pass, they could walk right in.
Exactly. This requires developers to enforce strict cryptographic validation on that meta object. If you don't cryptographically sign and validate it, an attacker can manipulate it to achieve cross-agent workflow hijacking.
And as I read through the sources, there's another glaring risk in this MCP update. They are introducing sandbox MCP apps and asynchronous background tasks, which is great for extending functionality, but it brings classic old-school web vulnerabilities directly into the AI execution ecosystem.
Yes, we are talking about stored cross-site scripting, or XSS, and resource exhaustion vulnerabilities natively impacting AI agents.
Wait, so an old web vulnerability like stored XSS is now a direct threat to a frontier AI agent?
Precisely. Because the agents are interacting with web elements and executing sandboxed apps, a payload designed for a web browser can now potentially execute within the agent's environment.
Which brings us full circle. If we synthesize all the sources from this week, a very clear, very intimidating picture emerges. We are watching the enterprise stack evolve from static code to dynamic, stateless, hyper-autonomous ecosystems.
Deploying infrastructure is faster than it has ever been, but securing it requires entirely new frameworks. The agents are incredibly capable writing parallel code, generating complex SQL, and operating GUIs, but the protocols binding them are introducing entirely new attack surfaces.
If you want to stay on top of these exact kinds of rapid shifts, keep tuning in to Deep Dive. And for even more daily news, you should definitely follow the show Cloud and Cybersecurity News on Spotify, which is a great resource for tracking these updates week to week.
The landscape is moving way too fast to ignore it.
It really is. As we wrap up today, I want to leave you with a final thought to mull over. We just talked about how AI agents are now operating legacy GUIs via Amazon Workspaces, and how the new MCP spec introduces the risk of stored XSS into sandboxed AI apps. Think about the collision of those two facts.
It's a scary thought.
It is. We aren't just dealing with simple prompt injection anymore. We are rapidly approaching a world where a compromised, forgotten web form from 2015 could theoretically execute a stored XSS payload that hijacks a 2026 frontier AI agent right through its virtual desktop. Are your legacy systems ready to be audited by malicious AI? Something to think about. Thanks for joining the deep dive, and we will see you next time.